Welcome back to the lab, folks. So, just got this new parcel here from PCBWay in the mail. Now, this, I'm guessing, is the boards for our little op-amp experimenter. And yeah, it sure is. What? No pen this time? Oh boy. Okay. So, let's have a look at these boards. This time I got them to send me 10 of them rather than 5, but it was the same price. $5, 10 for $5. So you can get 10 boards, I think it's 10 boards up to 100 millimeters by 100 millimeters for your $5. Don't quote me on that, but I mean, I got these for $5. And yeah, these are going to work out really well. So your op amp goes in the middle there, and then all your biasing resistors and capacitors, whatever you need to put on it, go in these spaces around here. And I've set it up so that we can have a non-inverting up there and inverting on the bottom. And we can actually tie the inputs together so we can have a look, feed one input in and see what the two outputs are like. Yeah, this is going to do very nicely. So I did this one with the ground plane on top and with the traces on the bottom. Somebody had suggested, it was a great idea. One of my subscribers suggested that I should just put a copper bore on the bottom. It'd be fine for a low speed circuit like this, and it'll save dumping all that copper. Now, I don't know if PCB reclaim the copper. They probably do. I would imagine they go through a lot of boards, so they probably have a process to reclaim the copper. But it certainly would reduce the chemical usage and everything else if you just leave as much copper on the board as you can. And for these low speed circuits, that would be fine to do. So the next one, that's what I'll be doing. Okay, so let me get a couple of these built up, and we'll come back. And what I'm going to do is probably going to do unity gain, and then I'll do another pair with some gain on them, different gain on both of them. And we'll hook them up and we'll have a look at them on the scope and try to see if we can understand how we can use these boards and how we can work with operational amplifiers. All right, we'll be right back. Okay, so I've got all the parts put together here. And what we're going to do is this one I'm going to set up for unity gain, and both on the inverted and non-inverted amplifier. And this one here I'm going to set up, I think I got the values here, I got for a gain of 10 on the inverting and a gain of 5 on the non-inverting. And we'll discuss the resistor values I use on these once we get them up and running and on the scope. But let me get started building them, and then once they're done, we'll hook up the scope and have a look. Here we are, we've got the Unity gain board all hooked up to the oscilloscope and the power supply. I've got plus and minus 10 volts going into it through here. Yeah, I've got a function generator coming in here, 1 volt peak to peak, and of course I'm monitoring the input and both the outputs with the oscilloscope. So let's get the oscilloscope up on the screen. Okay, the oscilloscope up here on the yellow trace, we've got the input. On the purple trace, we've got the non-inverting output, and on the blue trace, we've got the inverting output. And you can see here, if you look down at the bottom of the scope there, you can see that we've got the peak-to-peak readings coming out of all of them, and they match exactly. So we've got pretty well unity gain going through. The only difference between the inverting and non-inverting is the phase. So you can see that the blue trace is out of phase with the yellow, and the purple trace is there. So that's what it means to be an inverting amplifier. It basically inverts the input. Now, the way we work that out here, you can see here for the inverting amplifier, and the gain is equal to minus RA2 divided by RA1, and that's RA2 and RA1. So all we have to do is make these two equal, and we've got a unity gain. And I put 20K into each one of those. And here for the non-inverting, we look at this formula here. The gain is equal to 1 plus R2 over R1. So I've made R2 0 and R1 is open, so it's infinite. And so that term there, the R2 over R1 becomes 0, and we have a gain then of 1. Now, if you want to go back, if you haven't studied the first in this series, I'll put a link to it up there. But what it will do is give you some of the theory. If you don't like the theory, then that's okay. Just use the formulas, it's fine. You don't have to do a lot of math. You just have to be able to do enough math to get the gain that you want. But the theory behind it, how these are derived, is pretty interesting if you're so inclined. So in both of these I put in TL072 op amps. I happen to have quite a few of them, and it's an okie dokie. It's not the greatest op amp around, but it is a nice dual supply op amp. So one of the things about operational amplifiers is that the input is not dependent upon the supply voltage. So if we go and we change the supply voltage, so I'm going to lower the voltage down on the negative side, and that should control both of them because I have the supply set up that way. We're now down at plus or minus 8 volts, plus or minus 5 volts. So you can see that it's relatively independent of the supply voltage. Of course, if the supply voltage goes down below what the op amp is able to provide on the output, or below what the op amp will be able to do circuit-wise, it needs a certain amount of voltage to get its job done. If you go below that, all bets are off. But once you're in the range of your output and the supply rating of the op amp, your supply voltage is not going to make any difference. So you do get a good bit of supply ripple rejection with op amps. All right, let's get the one here with gain on it. And we'll hook that one up too. And so what I did here I put in a gain of 10. So simply we just put in RA, or R2 is actually 10 times higher than R1. So I put in 100K here and 10K here. So that should give us a gain of 10 on the output of this one. This one here, I was going for a gain of 5. So we already have a gain of 1, which is independent of the resistors. So what I had to do, it said had needed a ratio of 4. So R2 had to be 4 times larger than R1. So I put in 39K for R2. As close as I could come to 40K, and a 10K for R1. So that should give us pretty damn close to a 5 times gain going through here. So let's hook this one up, and we'll come back and look at the scope on that one. Okay, here we are. So let's see what we got here. We got, if you look at the pink trace there, or purple trace, whatever color comes across to you as, we've got 5.28 volts coming out. So that's pretty close to our gain goal of 5. It's a little bit less because we've got 1.1 volts going in. And then on the blue trace there, we've got our inverted amplifier at a gain of, we were hoping for a gain of 10. We got 10.6 volts coming out. So that's pretty close too. Like we should see 11 if everything is perfect, but you know, we've got tolerances in the resistors here, and we have to put up with a little bit of tolerance on the output, but we're pretty close to our gain of 10. So let me get a calculator and figure out what kind of gains we are getting. So there on the blue trace, on the inverting amplifier, we're getting a gain of 9.64 instead of 10. And on the other one, we're getting a gain of 4.8. So we're up by 4% on that one, and that's well within the resistors tolerance. They're 5% resistors. And on the other one, yeah, we've got even less. We've got 3.7%. So we're well within tolerances there too. So that's good. Some amps haven't let us down, and they're behaving exactly the way we wanted them to. So yeah, these are going to be great modules for us moving forward for doing a little bit more interesting experiments. Okay, on the next one, what we're going to do is look at circuits that involve capacitors in the feedback and see what we can do with them. And we'll give them names at that point in time, and we'll build up boards to look at them and see how we can maybe use these boards together. One thing I will note in the construction of it, using these little test points here, they are a bit of a learning curve to get them into place properly, and I tried to get them in beside each other so they won't go in really well on 0.1 inch centers. That's why I kind of spaced them out here a little bit so I could get leads around them. But they're very brittle too, so you got to get them in the orientation that you want, because if you try to bend one of them, you're more than likely you'll break it. So just keep that in mind if you ever do get these little test points and try to use them. This is my first experience with them. I think they're okay, but they're of limited use. It'd be fine for attaching up to a place like this where you want to use that as a test point. But for inputs and outputs like I have here, I should have just used the keyed connectors. So yeah, polarized connectors. And I will do that next time, and I may change these as well in the interim just for that purpose, so that it makes it easier to connect these boards together. All right, folks, that's all I really have for you today. I'd really like to thank PCBWay again for making this possible. And I'd like to thank you folks for coming out and joining me today. And we'll see you in the next video. In the meantime, do some electronics. Bye.